Good morning, good afternoon. How's everyone doing today? Who all do we have in the chat? Blake, good to see you here. What are we working on today? You name it, we'll work on it. Hello, Roshni, good to see you here. We need a little music right here. We got Muba in the chat. Points. Let's throw out some points. Points in the chat. What questions are there? We can do some Mubot there in the chat. Love it, Aces hate everybody. Love it. I've got so many Word documents open. So many. Control Shift W. Does that do it? Oh. Control Shift W closed them all. Don't save. I thought there was a way to close. Oh. Weird fact of the day. It's only 7 degrees in Orlando today and I am cold. Oh no, Colin. Good to see you here. Got to throw some points for Colin being here. What do people want to work on? Lachey, good to see you here too. Trying to get all my millions of Word documents closed. Oh no, I closed the chat. Okay, gotta get the chat going. All right, here we go. Let's work on the exact exam questions. What chapter do you want to cover? What chapter do you want to cover? I told 320 to come by. I'm gonna accidentally close the chat again. I'm closing all the can you explain how to do the inverse norm on the TI calculator? Yeah, well, I've got a really good video on that too, Roshni. And here's the thing too, if you can use the TI calculator, but if you're using the TI calculator and you're just now using it, it might not be the best thing to work the whole exam using the TI. You want to have done a bunch of practice problems with the TI. So here we'll do a practice problem where you would use inverse norm and the TI. So, and the reason I don't teach the TI by default is because, let's say, good answer right there, chapter 5. The reason I don't use the TI, I don't teach TI by default is because not everyone has one and we don't require it. So that way it's not like if I'm teaching how to use the TI calculator to solve the problems and you don't have one, then you're not like, wait, I can't do this. Ah! So let's do I'm closing literally endless Word documents right now. Almost there. So let's do a chapter 5 problem. That would be a good place to start. Put all the timestamps in from yesterday. So chapter 5 with inverse norm. Okay. Let's say example test problem. Stat 201. Stat 201. Example test problem. Okay. Let's do this. Here we go. Over to this main screen. Yeah, I think we'll do afternoon. I had to make some shifts to my schedule today, so it's exam day. It's busy day. Let me schedule those afternoon office hours too. Busy day. We'll do some afternoon. Oh my gosh, busy day. Woo! Hey. Okay, so with this right here, let's think about how I write a chapter 5 problem. If I write a chapter 5 problem, you're probably going to hear first that the data is what? No worries, we're going to practice right here, Blake. When I write a chapter 5 problem, what does Brian tell you usually? Like, what do I usually tell you? So think about what's important in chapter 5 problems. Like, what are the ideas that start up a chapter 5 problem? Like, the better, if you can write test problems, you're doing great. Well, you could get Z-scores. I like that right there. I could hand you some Z-scores so you could see Z-scores. You're probably going to be drawing out the curve. What else might you get? Well, not close, not Blake. Remember the mean and the standard deviation. Mean and standard deviation would be given to you. Trying to think what else. We might talk about a percentile on the curve. So all of these things right here are going to be in. Great job, Blake, and good practice. We're going to throw some more points. But does that make sense? Like, can anyone think of anything else? Like, we might be drawing out the curve. We might get the mean standard deviation, or we might have David and Elaine pictures. David and Elaine applet pictures. So there we go. Some main or empirical rule. We got to put empirical rule. You might have to use the empirical rule. Why is that weird? Weird. Why is that one weird? I have no idea what's going on. What's up, Snea? Good to see you, Snea. How you doing? So good meeting you, Snea. And good, it's awesome. I've got time before I head to campus and want to drop by and say hi. We got to throw 1,000 points for Snea being here. It's test day, Snea. So good to see you, Snea. I hope you're doing great. And so nice meeting you on campus. So good to see everybody right here. I just get, aw, Snea. All of those students I've had multiple classes and just boom. We still have Snea level. People are hitting Snea level now. You might see with people's points. It'd be so ironic if Abby right there had hit. She's at point hype level. but it'd be so ironic if she had just hit Snea level. So that is the Snea of Snea level right there. So that is awesome. How many points is it? I'm gonna write some test questions right here. That is the myth, the legend, not the myth. It's 80,000. So people have surpassed that. It's the 80,000 level mark. 80,000 to 100,000. Yeah, there is. Oh no, there's Shreya level. Oh my gosh, there's Shreya level. Let's add a Snea level right now. Snea, would you like there to be a Snea level? Now that we said it, let's do it here. Let's do it. You ready? We're gonna do this really quick. Then we're gonna do some questions. We gotta have a little bit of fun today. Let's make it. We're making it right now. We are making it 1.12. So here we go. Oh, I think Lachey will be there. Okay, so here we go. And there we go. Okay. So there is now a Snea, as long as you're okay with that, there is now a Snea level. There's Stat Nation Snea tier. So for all we have Priya after that. So there's all the different tiers. I like that, I don't know, just the history of our channel. So do you want there? Let me ask again. Do you want there to be a Snea level? You can say yeah or nah. Do you want there to be a Snea level to students who will achieve Snea level? Do you want that right there, Snea? Yes or no? Would you like that? You can be like nah. Would you like that to be you're part of the or nah? It's all right. I'm totally fine being like nah. It's all right. And so, what do you think, Snea? And then we'll do this problem here. Oh, that's what I thought, Snea. That's what I thought. So, Lachey, check your points again and see where you're at. And also you got a little bit more bonus now because I put it more incrementally. I'll try to add more incremental levels because the last few levels are less points. But we'll try to add more levels. But check your points right there. And if Mewbot's updated, no, so it should update. Mewbot's gonna update here. Let's throw out another 1,000 points. But Lachey, you should get the update because it's at 250,000 right now. So 250,000. When Mewbot updates, you'll see that you're there. I was on hamster tier for so long. Oh, thank you so much. Of course, Snea. Of course, Snea. Of course, I remember you. Like, like you took multiple courses, so of course. Right there. So Roshni's getting there too. Great job, Roshni. And if you ever with our top point getters or people take multiple classes, a lot of times I add it. So let me re-timestamp this and let's do a question from chapter 5. We'll do some inverse norm, but it's just so good seeing like current former students. That it really brightens my day. I've been doing a lot of cheating nonsense. Oh, I hate it. I like dealing with all the fun stuff. You're already at Priya level. You've already surpassed Shreya level. So there you go. Honor of many of our great students right here. But I heard early I'm not a myth. Exactly. At the MSBA. And then we met on campus, right? At the start of the semester. Try to remember everyone I met. And we met because you came up and you're at the front of the department and we were grabbing a duck and a shirt, right? So really awesome stuff right there. I'm trying to remember everyone I met. And all the faces. I got all the names. I got to put the faces and everything. It's really just nice doing that. Yeah, no, it's perfect. That's perfect. I was so happy to meet everybody. It's really just, it's great. Like I'm missing all my students. I miss seeing Blake and right there and Lachey. I want to see everybody and just say hi. So I'll be back around. Chelsea. I'll be back for Go with the Bunnies. So we've got all this information right here, right? This is a lot of chapter 5 right here. I'll be back on campus. We can even have checking normality. So these are things you should understand. So which one of these do you want let's put mean estimation. That's almost a requirement. What else should we write for this problem? We're going to write a problem right here, but tell me some things to include. Like pick 2 of these things right here to include in the problem and I'll do it. Pick 2 of the things. Percentile, let's do a percentile thing. That's going to be inverse norm, yeah? Yeah. And then let's throw on z-score. Okay, so this problem is going to be centered around the following ideas, and we could do some David M. Lane's too, or we could do percentile, mean, and standard deviation in David M. Lane pictures. So we'll do that here too, Roshni. We'll write one problem here, or I could include all this right here. I don't know why it's doing that. Okay, so let me go grab a David M. Lane picture. So Roshni, good stuff right there, and let's add it all in. And we could have a Blake level one day. We could have a Roshni level. Lachey's up there too, so we could have a Lachey level. Like the people who break the point scale, usually I like, okay, let's add you to the levels. You become part of the history. Helps me remember things too. That way, we get to like be like, oh, so and so. It's really great. Like Colin was just here. Colin, I love that Colin swings by. He's over at Disney. Snay as it said the MBA program or MSBA. That'd be insane. Yeah, make it happen. So here we are. We are on the normal curve. So a lot of times, yay, Lachey, that's awesome. Message me on Discord and I'll send you the whole list. Or I can just show it right now. I'll show it right now real quick. Here is the full list of levels. Yeah, I'm showing the levels. So here's all the levels right here. Everything. This is the inside scoop. These are all the levels right here. There's our meme tier right there. And we got True Stat Nation Legend right there. Everything is like Stat Nation this, and then you finally get to like True Stat Nation Legend right there. So I added you in right here, Snea tier. There's Priya tier. There's Hamster tier. There's Mewbot, Pint Hype. Pint Hype comes from Winter Mini Term. Pirate tier, Epic Wolf, Kayla, Shreya, Evil Tiny Brian, Galaxy Pog, all the different things right here. I need to figure out some more and maybe space them out a little bit more. I'm working on it. Thank you, Rashni. So, of course, Snail knows all the Kaylas. Kayla is a famous name in our class for all the Kaylas we've had. Many excellent Kaylas throughout the like one semester. We had like 3-4 Kaylas. They're all awesome. Shout out to Kayla G, Kayla B. Trying to think, there's another one I'm trying to remember. Also, gotta do this to resume. So if we're doing inverse norm, we're gonna hop over here. Thank you, everyone, bringing some levity. We'll get serious right here. We'll put on that serious face, bring in some levity and having a good time. What is currently being displayed for you on the screen? What are you currently seeing? Like, explain to me what you see. You should understand the picture right here and what you see. We've put on that serious face right now. What do you currently see on the screen? What is that thing that you see on the screen? What is that? What is that? That is showing you the what. I can tell you what it is, but you should see it and should say, this is the what of the what of the what. Great job, Blake, right there. That's the 90th percentile. Exactly one of the things I was looking for. So that's the 90th percentile right there, because it is. Because the top 10%, great job. Don't worry, you second guess. You're like, oh, it is the 90th. So this is the 90th percentile because it's the top 10%. That's where the 90th percentile is. And then this is the what for the 90th percentile. This is the what for the 90th percentile. That is the what for the 90th percentile. That is the what. That's the Z-score. Correct. Because it's on a curve with zeros and ones. It's on a curve with zeros and ones. So that's the Z-score for the 90th percentile. Like, the first thing you want to do if you get a picture like this is to just understand what you are seeing. And that's what you want to first know. Okay, it's got a mean of 0 and a standard deviation of 1. That means this is what we call the standard normal curve because it's been standardized to Z-scores. And thus, we are going to use Z-scores. Mean and standard deviation is part of this question. Percentiles and David M. Lane, we have created a question right here using these topics. So now we just need to write something that kind of conforms to this. So we could say something like, race times are normally distributed with a mean of, be careful, this one's kind of a little bit of a trick. Awesome, Snag, good seeing you. Thank you so much, and good luck on the exams. With a mean of, and a standard deviation of 3, you are in the fastest 10% of racers. What was your race time? Okay. So this one right here, Evan, we're dropping them all the time right here. So I can take a pretty good guess at this. Does anyone have a guess at this answer? Be very careful. There's a trick to this one. I added an extra step. I made it a little more difficult. So always think about what is it asking you, because it's easy to just like flip the curve or do something wrong. So if you want to just take a guess right now, I can tell you if you're kind of close on your guess. Now, if you see right here another mean and another standard deviation, what should you probably do? Look, if you see right there, you have the standard normal curve. Oh, be careful. Wait, but I got caught by the trick, Evan. You are in the fastest. You're in the fastest. Don't worry. I did a little trick right there. Good guess for the other one, or decent guess for the other one, but you're in the fastest. So if we see a mean and standard deviation that's not on our curve, we're immediately going to do the following. We're immediately going to go down here and add in this mean and this standard deviation. We're going to add those in down here. Does that make sense? Like I would add these in down here, the mean and the standard deviation, to give this curve context. Wait, careful. You'll see there's a trick. You're in the fastest. If you're in the fastest, then your time would be what, or higher or lower? If you're in the fastest, your time would be higher or lower. Oh, no worries. If you're in the fastest, would your time be higher or lower? Yeah, don't worry. I'm trying to do a few tricky questions right here. So everyone sees writing 3 each time to this. So I'm just showing the standard deviation units and just drawing it out. So you can see this is where 26 is at. This is where 29 is at. This is where 17, 14, and 11. So good guess. And good guess, William. Good to see you here, William. Can you show the z-score again? Yes. With the z-score, you should be able to find the answer. Now, here's the thing. If this is the 90th percentile, this is the 90th. Does everyone understand why this is the 90th? Why is that the 90th? Because it's the what? Why is this the 90th right here? Can you explain to me why that is the 90th percentile? Good guess, Evan. Yes, that's closer. Why is that the 90th percentile right there? Oh, and you can't see the z-score still. Oh, come on. There we go. Why is that the 90th percentile? Sorry, Blake. Why is that the 90th percentile? That is the 90th percentile because, well, it is the slowest runners and it's the top 10%, right? Like this is the top 10% right here. So the top 10% means 90% is below it. Does that make sense why it's called the percentile? And that does seem, that's probably right, Blake. Great job, Blake. Throw some points in the chat. That does seem correct. Yep, that does seem correct now. I've been trying to solve it, and I think that's it. Blake's got a great answer right there. Excellent work. Because now we would know that the 10th percentile is where? Where is this spot on the curve right here? Where is that spot? So Blake wanted to know the z-score, because if this has a z-score over here of 1.282, then the 10th percentile would have, good job, William, right there. And the 10th percentile would have a z-score of what? What is the z-score of the 10th percentile? What is the z-score of the 10th percentile? So these are the steps right here. A few people have solved it already. Negative 1.282. Negative 1.282. It's just on, does everyone see it's got like symmetric on the other side of it? So it's symmetry on the other side. Great job, Roshni, right there. So now what does this tell you? The answer to the question, so finish my sentence right here. The answer to the question is blank blanks, blah, blah, blank. The answer to the question, and you can kind of see it right here visually. The answer to the question is blank blanks below the blank. The answer to the question, if you see it visually, is blank blanks below the blank. 1.282 and then standard deviations, right? 1.282 standard deviations below the mean. And that's what I'm showing right there with the colors to be like, okay, now we need to actually go 1.282 standard deviations below the mean. So we do that. We go to the mean. So mean plus, and you can do plus because the standard deviation is or the z-score is negative. So z-score times standard deviation, the mean is 20. The z-score is negative 1.282, and the standard deviation is 3. And we'll go with what Blake said right there. I think you said it's 16 point, where is it? 16.154. Does that look, that 16.1, does that answer right here? We'll show it on the calculator if you want. Does that look to be about right there? Does that look, if you trace down right here, does that look to be about right there? Does that look to be where 16.154 is about? Does that look to be about where that's at? And then we're going to show the inverse norm way of solving it. It does look like it, right? What if I told you I could find the 90th percentile really quickly? What if I told you I could find the 90th percentile and that the 90th percentile would be 23, I'm trying to think. 23, I can find it really quickly, give me a moment. 23.846. 23.846. Is that right? 23.846. Here we can do it. 1.282 times 3, and then plus that 23.846 for the, and that's the 90th. So what I actually did was I found the difference right here. Does that make sense how I did like the final? I found the 90th by knowing that the, there we go. I found the 90th by knowing that the 10th percentile, he's a wizard. I can't do it today. I found the 10th knowing that it's that far below, so the 90th is that far above. This is right here. We'll put it as a quote. Good quote time. He's a wizard. Let's drop it as a quote. Does that make sense how I did that quick solve right there? Quote 307. He's a wizard. Does that make sense right there? You got it. We got a quote in the chat. Brian, you're a wizard. Should be Brian. We'll put he's a wizard on here. I like that right there. And we'll throw some more quotes, Evan. Drop some more quotes. We'll do it. How are we doing on this? How are we doing on this understanding of how this was solved? And then to solve it on the calculator, if I asked you for the 90, let's say the fastest 10%, you ready? So now we're going to do a calculator solve. So what are, now careful, this is a different question. What is the time of the slowest 10% of runners? Solve with TI. Okay, now we already know the answer to this. Does everyone agree? What is the answer to what is the time of the slowest 10%? Use the information on the screen to help you solve. We already did a solve for this a moment ago. What is the time of the slowest 10%? Who can solve that right here? I'm going to highlight where the answer is at. What is the time of the slowest 10%? And then we're going to use the calculator. So what is the time of the slowest 10%? The slowest, which would be the 90th percentile. Use the information on the screen. Not close-ish. Well, so you can solve using the z-score down here. I've got everything on the screen now. So don't take a guess. Use, instead of doing the negative z-score, you can do the positive, and you can solve. And I've kind of got the information up here with what you need. 23.846. Does that make sense? So now we just use the positive z-score instead. So you could just solve using this here because you're just going to use and add this way on top of it. So 23.846. Now we're going to use the calculator to solve. So the reason we're showing this at the end is because this is not required on the test, but you want to go to the calculator and go to inverse norm. So inverse norm takes 3 arguments. It takes percentile, and then it takes mean, and it takes standard deviation. So what should be your inputs to this? So fill in the inputs, just add them with commas right here. If you do inverse norm, it takes percentile, mean, and standard deviation, and it will output the answer for you. So what should be your inputs for the percentile, the mean, and the standard deviation for what is the slowest 10%? Be very careful. I wrote it this way as a trick. So you want to enter in the percentile, the mean, and the standard deviation. What would be your inputs on the inverse norm if you're using the TI calculator? Careful, Roshni. Good. And that's why I threw the trick on here. Everything is right except that. And so when you do that, Roshni, what answer do you get? So do that in the calculator. But then if you've drawn it out, you can be like, wait. This is for TI calculator's inverse norm function. So Roshni, do that and then be like, oh, wait a minute. Oh, okay, wait. And then if you click enter on that, Roshni, and you look at your answer, I think you'll see we're asking about the slowest 10%. So what do you think needs to be changed, Roshni? And good work there, Roshni, because then if you draw it out and you see it, you're like, okay, wait a minute, I found this side. So inverse norm actually solves this for us. It does the entries like, and so this is only for TI. Do you have a TI calculator, Evan? And I have videos on this too. You want to enter a 90 here. And so these inputs right here can actually be input here. So you can do it on the TI calculator. So you can do it. So everything you're doing there, right here on this side of it is inverse norm. Does that make sense? This side of the David M. Lane is the inverse norm on the TI calculator. And then the other side of it, and good job, Lachey, right there too. So we could do another one. We could do it, if you, who wants to do a quick solve on a TI calculator problem? Does anyone want to do a quick solve? It's under stat distributions. Let me pull up the video so I can show it. Let me get my TI calculator videos. TI calculator videos. TI tutorials. Where are they at? Oh, I gotta scroll down. Got too many playlists. Tutorials. TI tutorials. Here we go. But I have a TI plus. Good to see you here, Wes. A student. Okay. Here we go. There's the 5-number summary. And where's my inverse norm? So normal CDF and inverse norm. So these are quick videos which show you how to use things like normal CDF and inverse norm while also showing the David M. lane right here. So I show the entries to the David M. lane, and then I also show you what you'd be entering in. So here's the inverse norm, a 3-minute video. So right here, I have the TI 30X. Does that have the inverse norm availability? You want to go to stat and distribution. Where do I show that? So you want to go to, I'm probably saying it. You want to go to stat. I'm going to click it eventually, right? Stat. Click the stat button. Second. Oh, second distribution. You want to go to second. I haven't done this in a while. Second distribution and scroll down to inverse norm right there. Don't have that. So you want to go to second distribution if you have it. So that's why I don't do it in class, because not everyone has this. And then you can do it with the David M. lane, and we show you the pictures. But then a lot of times I've had people do it with the TI and be like, I have no idea what I'm doing. I'm just punching in numbers. I don't know what it's actually doing right here. Yeah, so these right here, I'll drop the link to it. I don't think we have a MuBot link to it. But if you want, I go through everything, especially for the last test. I have short videos right here going over how to use the TI for everything. Would actually do it the hard way for once. I think as long as you know the applet pictures, you're good. Yeah, you can use the TI on the exam. You can use pretty much any calculator unless it's like your phone or something, which I think I sent that out this morning. So don't use your phone. Whatever you do, don't use your phone. No notes, no phone. Don't do that. Don't do that. Don't do that. It's so basically just does it for us. But the problem is you have to know exactly what it's doing. So the understanding to use the calculator to know exactly what it's doing is kind of up there with being able to read the curve. Yeah, so that's the thing. So an iPhone, that is correct, Blake. He'll do a second question. You ready here? What should we change about this question? We'll still use mean and standard deviation. That's kind of a must. Pick 2 things to use right here. Let's do a second question. We can solve it with the calculator too. 2 extra things you want me to use. Empirical rule right here. Okay, and what else? Empirical rule. Then we probably wouldn't use pictures. So let's do an empirical rule thing. And drawing it out. We got drawing it out. We definitely do an empirical rule, drawing it out. Anything else? So empirical rule, drawing it out. That sounds pretty good to me. Okay, so empirical rule, drawing out the curve. Okay, so let's take a mark right here. Stat 201, example, test problem, chapter 5, empirical rule. Okay, association correlation. We could do that here. We could do some association correlation. Okay, so with these problems, it usually says use the empirical rule 68, 95, 9.7 to solve the following problem below. You find out that the average wait time at the store is normally distributed with a mean of 8 minutes and a standard deviation of 2. Here we'll do an easy one to start. Ready? Easy. What is the interval for the middle 95% of wait times? How quick can you get this one? This should be an easier one right here. Don't worry if you can't get it. My character is resetting. No resetting RAM. So this is like a level, I would say, I like to rank questions. Sometimes I'd say it's like a 1 or 2 level question. Like this is, don't worry if you get it wrong. So great, yeah. So the first thing you should do is you should identify the mean and the standard deviation. So remember, we like to identify key parts of the question. We've got a mean right here of this and a standard deviation of this. and we know it's normally distributed. Where does it say normally distributed? Okay. So when you write this out, you say normal. That stands for the shape of the curve. And then you have a mean as the first number and standard deviation is the second number right there. So we got 8 and 2. So when you draw the shape right here, you draw the following. And you, once again, the color right here representing the normal. And now we put the mean right here at the center, and we go up units of standard deviations when we do this right here. I'm going to write a more difficult question here in a moment, but the drawing is going to help a lot. The mean goes here at the center, and then we go up in units of 2 each time. Then what else do I like to add below my curve? After I do this right here, and I put in these, I usually, if you've ever watched me draw these, I like to add in a what? What do I like to add in? Great job, William. Also, let's throw William some more points. Good correction, William, right there. William, 1,000 points. Keep it up, William. Good answers in the chat. We like those answers right here. We'll throw regular points. We'll throw 1,000 points on top of that. I like to throw those Z-scores. I like Z-scores. So here's 10. Here's 12. Here's 14. If you're doing this on your scratch sheet of paper, then you can just like erase the numbers. So usually, if I was doing this for the test, I'd probably put the Z-scores first. So if I'm doing this for the test, and I'm drawing a curve, so I don't have to redraw it every 2 seconds, my best idea for the test is to put the Z-scores here originally, because the Z-scores aren't going to change. Every time you do one of these problems, it'll have the same Z-scores, but then you can change right here. This would be 8, and you could erase these after you do it. Just kind of write them very lightly with your pen. I think this, it doesn't. I thought it did like light drawings right there. So you can write these numbers below. There we go. And that's the context right there. So this is the standard normals mean. This is the context. And then the units we're going up right here are 2. The units we're going down here are 1. So now when we do this right here, we need to put the empirical rule numbers on here. And we can see the following: 68, 95. And we just found the answer right there. And then last but not least is 99.7. So 99.7. 99.7%. Okay. So why would you need to erase them? If you're doing a different problem, you could come in here and just erase these numbers along the bottom. And then look at that. You just have a standard normal curve. Does that make sense? To Evan's question, you could just rewrite now, like another problem asks you like another standard deviation, another mean. You just change the numbers there. So that's like just a good strategy to be like, let me draw a good curve. Let me make it look nice and neat. Let me put my numbers. And then I could just like redraw it. You don't have erasable pins. Oh, no worries. No worries. Just it's good practice. The more you draw it, the better practice you get. So with this right here, let's go. So now when we look at this problem, we're looking for the middle 95, which has already been identified on here for us. It's going to be these answers right here. Do remember we're looking for the context, which is going to be the answer of 12 and 4. But let's do a more difficult problem that asks you. So we're changing the problem now. And the problem says, what percent of times are between 4 and 10 minutes? Who knows the answer to this? I'm not going to show you the curve yet. I want you to draw it out and you try to answer it. I know the answer right now. What is it? What percent of time are between 4 and 10 minutes? There's a lot of good ways to solve this. What percent of time are between 4 and 10 minutes? It's close to 90. It's not quite 90. It's close. It's a little bit lower. Don't worry. Draw it out. Draw it out. Take a moment. Draw it out. Like, just take a moment. Not 95. Not 70. Good guesses. But draw it out. Draw it out. So you always want to draw it out. And I'll draw it out here in a second. We'll see if someone gets it. We'll give it 30 seconds right here to see if people get it. That's Roshni, really close right there. Roshni, carry some decimals. Evan, close, but carry the decimals. William got it. Let's see how William got that answer. Great job, William. We're just going to go on a limb and make William a moderator. Great job, William. That is correct. So let's see how William got that answer. So you ready? Here's how he got the answer. Let's find out. You ready? The bell's about to go off. Okay. So if you look right here at the curve, so the curve, once again, we always say draw it out. So we need to put marks on our curve on 4 and 10, right? So 4 is down here and 10 is over here. Now I'm going to cut this into two pieces. You ready? I'm going to cut it into this piece. We're going to call this piece 1. I'm going to call this piece 2. Can anyone tell me how big piece 1 is? So how big is piece 1? So find for me how big piece 1 is. This piece right here, how big is that? And then how do you know that? 34. Does that make sense? One piece? We're talking about one piece here. So that one right there. So that is 34. Now I want you to talk to me about piece 2. It goes from 0 to -2. So if you're wondering that, they divided 68 in half to get the last one. 68 divided in half was the last one. So we know that this right here over on this side is 34. Like that piece right there. That piece is 34. And then Blake sees the other one with the same trick, that this is 47.5. So how'd you get 47.5% right there, Blake? How'd you get that that is 47.5? And then Wes is doing it in another alternative solve way. Great job, Wes, right there. Wes did another solve. So you see, you just need one way to solve it. And so Blake's doing that way too. Or you could just take half of 95. Another way to solve, got the hiccups. Another way to solve that one there is 95 divided by 2. And then the 13.5 is a little bit tougher to get. The 13.5s, if you know things like 0, whoops. If you've memorized these numbers, it can help a lot. The 0.15, 2.35, 13.5, 34, and then it's symmetric from here down. So you can get the area underneath all the parts of the curve if you go through and solve for each one. Oops. And then you could actually add these up. But you can also solve them out. In between second and third is 13.5. Second and third is going to be 2.35. In between first and second is 13.5. So this right here. So we have the answer. I think one of the easier ways to solve this right now is to realize that this is half of 95. Does that make sense? Does that make sense? Like, I think an easier solve at the moment is to say this is half of the 95. This right here, this 34 is half of the 68 because it goes from 0 to 1 and -1 to 1 is 68. So this is half of 68. This goes from -2 to 0. So that's half of 95. So the answer to the question, great job, William, right there, getting it pretty quickly, was 81.5 because we're just going to add up those two numbers right there. So that's probably one of the trickier ones right there. And just practicing these, seeing how to solve them is the best way to do it. Should we do one more on these, like kind of similar problem right here? What do people think? Do one more, see if just practice right here. We're just rewinding time, but just a similar problem right here. Let's do it. Good to see you here, Natalie. Sick, okay, for sure. Sure. Let's do it. Here, once again, I'm not going to show you the curve because I want you to draw it out. That's where the real practice is. So, what percent of times are between? This is going to be a tricky one. This is a tougher one. 2 and 6 minutes. All right. This is a tougher one. Yeah, I think we'll do them later today. I thought I was going to have to cancel, but I am doing all right. Woo! What percent of time are between 2 and 6 minutes? Okay, so I'm even having to think through this. Okay, wait. Okay, I think I got it. It's such an exact number. This is probably one of the hardest ones I've ever written. I think I know it. Yeah, I know it. You have to tell me the 2 decimals. This is one of the toughest ones we could ever write. So if you can get this one, you really know the curve. And so let's see what people get. See if anyone gets it. We'll give it 30 seconds right here. What do people think? So draw it out. If you don't have the answer yet, we'll be showing how to get the answer. If you're practicing, make sure to try to draw this out. The more practice you have drawing out the curve, the better you get at it. So what is the answer? You'll need to go to 2 decimals. You'll need to go to 2 decimals. What is the answer? Not quite 26. The last number there is kind of accurate, but not quite. Very close, Blake. It rounds to that. Very close. It does round to that. So between 2 and 6. Okay, so between 2 and 6 is between here and here, which is here, because that's where 2's at. That's the context. And 6, which is right here. Does that make sense? Great job, Lachey. Got to throw Lachey some points right there. That is correct, Lachey. This was, once again, I said this is kind of like the toughest I could write. So great job, Blake. Blake and Lachey got it exactly. So when you do 99.7, what percent of area is outside of 99.7? What percent of area is outside total of 99.7? Like if you have 99.7 on the inside, what percent is outside of 99.7? So what percent? 0.3, right? That means each of these is worth 0.15. Does that make sense? Each of these is worth 0.15 right there. So 0.15 on each side, 0.3 total. Now, we just found that this area, which we're not interested in, we're going to put a red for not interested in. This area right here is worth how much? Between here and here is worth how much? And there's the hint up here. So that area I've just outlined in red is worth 34. Great job right there. And why are we doing this? You'll see here in a second. We are not interested in those red areas right there. We're not interested in this area. And we are not interested in this area. We are interested in this area. How much area total have I shaded on the screen right now? By going to 0 and going below it, how much area have I shaded total on the screen? How much area have I shaded total on the screen? This is probably one of the hardest versions of it. Correct, Natalie. Natalie, great job. Got to throw you some points. That's Natalie, you're seeing it. Natalie saw that we've shaded 50% total, and thus you can subtract off the from 50%, because there's 50% shaded total. I knew it. I keep making my mouse slower. From the 50% total, because below 0 is 50%, 50% minus that 34 minus that 0.15 right there. Now, an alternative solve, if you know the numbers on the curve, which maybe some people did, is to go right here and know that this is, my gosh, my brain's breaking, 2.35, and this is 13.5. So if you know those percentages between, you could simply just add those and get the right numbers. Does that make sense right there? That if you know the alternative solve of just all the numbers, so you could add those numbers, or you can also confirm the answers. Yes, correct. So, well, but we're not using this right here. So the alternative solve would be to add 2.35 plus 13.5. So that gets right there. Does that make sense, Wes, right there? We're not using the 0.15. That's actually being subtracted off. So it's 15.85. This is probably one of the toughest versions I could write of it. So not all of them are this tough. That is the toughest empirical rule kind of regions to do, unless I did like some like adding up multiple regions type thing. But that is the hardest right there. That's like a level 9 or 10 empirical rule question, like using the empirical rule numbers to know, because it's a very exact, it's not using the 0.15. Because what if we just change this to this becomes a much easier question right here if I say below 6 minutes. So below 6 minutes, can you solve that pretty quickly? We just switched it. 320, yeah, let's do that. We'll do some 320 here. And so, good question, Abby, right there. Below 6 minutes. So think about how that changes the question. $16, yep. So now you could just go below, you're just shading the, does everyone see where we're going below 6 minutes? So you're just going this way, and there's the answer. So it becomes a much easier question. We say below 6 minutes. Trying to think what else, but like this is like a level 4-3 question now. It's this the knowing to subtract off that little tiny bit makes it a much more difficult empirical question. If we were going to solve that by using the calculator, I probably wouldn't. The way to solve it on the calculator, and you got to be careful. If you think you get something wrong because you entered it in the calculator, let me know. I probably would, if it says use the empirical rule, use the empirical rule. And then we're going to do Abby's question here next. But if you wanted to solve this on the calculator, it'd be norm CDF, and then you would enter in your lower and your upper. So enter in negative 999, comma 6, comma, I think this is right, mean standard deviation, so 8, comma 2. I think that's right. Could you go through how to calculate percentiles? I'm blank on that. Good question right there. So if we were to ask, I'll do one more on this, Natalie, and then we're gonna do Abby's question. Let's do a percentile empirical rule question. So we'll do a percentile empirical rule question. I think this will do it. Can anyone confirm on the TI calculator that this gets you the answer? It's going to get you like 15.68 or something. We can look at what the David M. Lane says for it. The David M. Lane says the answer would be so 8.2. Oh, we want to go over here. 8.2 and below 6. It's saying 15.86 on the calculator. Yeah. So if you look at how close, it's very close to 16%. Great job, Roshni, right there. And it's just entering in the same things. But on the calculator, you have to do a between. So you have to do like -999, give it a lower, and give it an upper. So you notice right here, these are the same answers between these two buttons right here. So maybe just small decimal differences that don't even really matter.
It doesn't matter.
So you can do these on the calculator, but if it says use the empirical rule, I would use the empirical rule, which is the percentages. But if you feel like you got counted off because you used the calculator, just let me know. Be like, hey Brian, I was just a fraction of percent off right here because I used the calculator. I'll probably say you're fine. Because I mean, if you know use the calculator, that's good too. Empirical rule you can carry with you at all times. So that's why we like to talk about the empirical rule. Let's do one more of these, then we're gonna do Abby's question right here. So this is using the normal curve, and we've been talking about different problems, but we're switching it up right here to now draw out the curve, mean and standard deviation, empirical rule with percentiles. So now we're tossing in the idea of doing percentiles. So we're just choosing some of these. I got good job, Evan, right there. Yep, that is the percent right there. That would be the percent below. So then you should be like, oh, that's basically 16%. Will there anything learned from Excel in the exam? Yes, pivot tables, pivot charts. Correct. You should be able to read them, understand them. If you did the pivot table assignment, you should be good on them. It's basically like, can you understand a pivot chart? Do you know what we do when we make pivot charts? So in between second and third z-score, there is 2.35. Correct. Correct. That is correct. Above 2 is 2.5. Here, I'll show that here real quick, Wes. Above 2 is 2.5, but in between 2 and 3, so you see how 95 right here, if you go above 2, then that is 2.5. But when you go between 2 and 3, it's 2.35, and above here is the 0.15 we just talked about. So if you add up these two values, that's where you get the 2.5. So 2.5 is above 2, but between 2 and 3, yeah, so hopefully seeing that right there. So when you go above 2, it's 2.5, 2 standard deviations, but between 2 and 3 is 2.35, and above 3 is the 0.15 remaining. That little tiny sliver that comes from going outside of the 99.7 right here. The 99.7 has remaining on the outside of it 0.15 on either side. So that's where those numbers come from. Yeah, nice job, Wes, right there. We got to throw Wes some points. And good to see her, Wes. So, Wes, I told my mom, I literally said to my mom, I said, you'll never guess who's in my class. She said, who? I said, Wes Turner. And she goes, really? And I was like, not Wes Turner we know. And she was like, what? And I was like, there's more people named Wes Turner than one. But I got her with that pretty good. I talked to her this weekend and she like, yeah, she was like, what? I should tell Wes. I should call up Wes and be like, hey, I got a Wes Turner in my class. But it was really cool. It was a fun little messing with I just mess with my parents. That's what I do. You get old and you mess with your parents. Okay. Let's do a percentile question right here. Then we're gonna do some 320. Cracking everyone up in the chat. Love it. Okay, so you're yeah, it's like if you have a name of like one of my good friends growing up, I gotta give shout outs. Gotta give shout outs. That's awesome. And I'm so glad I got to meet you too, Wes. Because you were talking all the sports stuff. That's really cool. I always try to like connect the memories. Like you're talking about all the sports stuff you're doing, like with I think you're doing sports. I'm gonna be, yeah. I'm trying to remember because you were talking about all those things, and it's just really exciting. All the sports. You could remind me if you want. It's not sports analytics, is it? Because now you're doing certain things with sports. Like hey, let's do a question. You ready? Your wait time is in the 97.5th percentile. Tell me that's what it is. That's what it is. That's what it is right there. Thank you, William. I appreciate that. Intern for Vanguard Sports. That's awesome right there. Yep. Percentile. What was your time? Okay. Oh, thank you, Wes. I appreciate that. No, it's close, Evan. Close. Thank you, Roshni, right there. I really appreciate the positivity. I always we deal with so much craziness. I hate dealing with negativity. I try to never get in a negative mindset. It's really tough. And I always I want to bring that positivity to my students. There's so much negativity out there in the world. I want you to have positivity. I want you to have a reason to smile. So that's what we try to do right here. We have a little bit of fun. We do some stats too at the same time. So if you notice our 97th percentile, does that mean when you see 97th percentile, are we on the right or the left of the curve? When you hear 97th percentile, are we on the right or the left of the curve? If you hear 97.5th percentile, 97.5 percentile, we're on the right side of the curve. Because this is the 50th percentile right here. That is the 50th percentile. Now, what you could do if you know these numbers is you can instantaneously know, because that's half of 68. Remember how this is 68. So where is this mark right here? This is the what percentile right there. So since you know that there's 34% between 0 and 1, 10 is the what percentile. 10 is the what percentile right there. 10 is the what. It's the 84th. We're just adding on to 50. So if we're talking about percentiles right here, that's the 50th at the center of the curve because it's the middle. And then this would be the 84th. Now, if you also know the other the numbers we've been talking about, the 13.5, what do you notice? And we'll just add up right here. This is going to be the what percentile right here. And then there's another alternative solve for it, which I would suggest too. That is going to be the what percentile there. That is going to be, drumroll, that is going to be 97.5. Great job, Sarah and Lachey and Natalie. So now I want you to think about this, though. Check this out. You ready? If that's the 97.5th percentile, how much area should be above it? If this right here is the 97.5th percentile, then how much area should be above it? Careful, not 0.15. Good job, Natalie, right there. We're going to throw some more points. The 2.5. Does that make sense? Throw 1,000 points. Remember, we're here to practice. We love it. Great job, Natalie, right there with the recovering the 1,000 points. Excellent work. Right here, the 2.5. So does this make logical sense that the answer to this question is what? What was your time? Use the information on the screen if you've been following along. If this asked you this on the test, no worries, Natalie. What would be your answer right here? You would put what into the blank on the thing? 12, exactly. The z-score is 2, and so the answer to the question is 12. Your time is 12, and you're 2 standard deviations above the mean. So great job there, 12 minutes. I just want to give a big shout out because I'm trying to remember who it was, but I had one student who had over 100. I think here it was. Wait, there are blanks. There are blank. Yeah, no, it's just like Canvas content. Just like Canvas content with multiple choice, numeric entry, you name it, different types of questions, true, falses. We're gonna do a lot more in class today, and I know what's on the test, so come to class because I know what's on the test, and I sometimes don't, we'll teach into the test. An outlier can do anything except outliers don't change the median and IQR. Outliers can do anything to correlation. Yep, and Wes, if you put that in and you put that on because that's like the exact answer right there. So if you put that in and it told you were wrong, please let us know. I would correct that. So you could go right here and go to the top 2.5%. And there it is right there. So if you were to, you will know your score after the exam. You shouldn't be able to see your answers, but you will know your score after the exam. And this is the top 2.5% right here. It's because between the middle 95 is actually, or the middle between -2 and 2 is actually 95.449. So we round it to 95 when we say 68, 95, 99.7. So due to rounding. But I do want to say just don't worry about getting stuff wrong here, because I had one student had over 100 in the class and they would regularly get stuff wrong in the chat. So if you were watching the chat, you would see me being like, oh, that's close, so-and-so. Oh, that's close too. Oh, you're really close. They had over 100. I can't say which one it is, but they're past student now. But I just remember that and like people being worried. But do you remember anyone in the chat in any of the class getting anything wrong? Oh wait, Natalie, wait, careful. We gotta. What can outliers do to correlation? Let's do it. You ready? We're reviewing for the test. Brian's trying to. I'll tell you stories other times, right? So what can outliers do to correlation? You ready? And Natalie, we were throwing Natalie 1,000 points right there because Natalie, you might have just saved someone a point or two on the test. Outliers can do anything to correlation. So you ready? When it comes to correlation, I got to go to view. When it comes to correlation, you have a bunch of points down here that look like a blob. You have a bunch here. We'll throw a quick thing on correlation right here, and then we're going to try to throw some 320 in on this. You have a bunch of points that look like a blob. A blob is going to have a correlation close to what? A blob is going to have correlation close to what? A blob of points is going to have correlation close to what? 0. Do you see it up here in the corner? So you want to look at this number up here where it says R. That's the correlation. And then I add 1 point over here, and boom, it's got a correlation of 0.8, very strong, or 0.9. Or I add a point down here, and boom, it's got a negative correlation of 0.68. Or we have a line. If you have a line of data, what does a perfect line of data have correlation-wise, if Brian can draw a perfect line? A perfect line of data would have a correlation of what? A perfect line of data, R is correlation, would have a correlation of 1. So, but what if we add 1 point over here? Boom, now the correlation is not even there. The correlation is basically 0. Does that make sense? Can you demonstrate correlation that'd be close to -1 or +1? Mm-hmm. Perfect +1. So what does the negative and positive indicate? If it's -1, it just indicates that it follows a what and goes what. If it's -1, it just indicates that it follows a what and does what. If it's -1, -1 is just the negative is just the direction, right? So this is negative because it goes down, and it's 1 because it perfectly follows the line. Now, if I start putting points further out, do you notice how now it's not as strong? The closer it is to the line, the closer it is to negative or +1. The negative just indicates the direction. So if I start putting points closer, watch how correlation starts to go up a little bit. Do you see putting points along the line makes it stronger? Putting points away from the line makes it weaker up there. So you can see it gets weaker and weaker as I add points that are further away, and we get a weaker relationship from the strong linear that we had previously. That's why I like showing things right there visually to be like, okay, like if you follow a line, that's linear correlation. The direction, positive or negative, just indicates does the relationship go up or down. R squared is what is called the coefficient of determination. It is literally just correlation squared. It's going to be in chapter 7. Wes, we got to throw you 1,000 points for the advanced question right there. That is chapter 7, linear regression. And so R squared is known as the coefficient of determination. You don't need to know that word, but it's the percent of variation in Y explained by the variation in X. So right now, X explains 16% of the variation in Y. And how do you think we find R squared? Not on this test, though. How do you think we find R squared? How do you think we find R squared? Nah, we do it in little bits. Little bits. We do it in little bits. Is it hard to find R squared? Is it hard to find R squared? Square R. And then R squared is always positive because it's a percent of variation. So to Abby's questions right here, we're going to switch over because this is a really great segue, right, Allie? Sorry, Allie, I said Abby. I mean, right, Abby? This is a perfect segue because Abby was wondering about, can you drop the question again, Abby? Because Abby's currently covering also correlation. So we're going to talk a little bit about correlation, but at the 320 level. So this still applies to 201. Assignment. So this still applies, and Abby dropped the questions. So for increasing X, there is a, well, that wouldn't be the slope. So the slope of this, if we want to get the slope, we would need to go right here and do a linear model. So check this out. We have the horsepower of the car explained by the weight of the car. So this is the horsepower of a car explained by the weight of the car. And so as the weight of the car, for cars that have higher weight, they generally have higher horsepower. Does that make sense? Cars with higher weight generally have higher horsepower. How to put R into words? So let's look at the correlation between these two variables. So to look at the correlation between these two variables, I'm going to run the associate function with the exact same inputs. Does this make sense here, Abby? Like I'm running the associate function and I get a correlation of this. Now, should we use, and good to see you here, Emily, should we use Pearson or Spearman? Should we use Pearson or Spearman here? And I see some issues. So 201 won't know about Pearson versus Spearman, but 320 will. Should I use Pearson or Spearman? So I'm going to look at this right here, and I would say Spearman, correct, because I see this. So what issues am I seeing, Abby? It might be an issue of this, or we might say it's an issue of like this. So why are we using Spearman? Like, let's justify the reasoning for Spearman right here. Oh, no worries, Blake. We'll answer. Ask away. Outliers and heteroscedastic. Exactly. So we've outlined the outliers there in yellow. And that's why we say QQ straight enough. No outliers. QQ straight enough. No outliers. Great job, Sarah, right there. And then heteroscedastic means plot thickening. So you can see it's getting thicker in this area. Like the points are spreading out more. And then the outliers are things that go away from the bivariate relationship. So because of this, Abby has decided to use Pearson correlation, which is rank based. So when you do Pearson correlation, it puts ranks in all these, like this is the first, the second, the third, the fourth, the fifth, the sixth. So let's say we have 40 points. This point over here can only be 0.40. So if it moved over further, it can't be extreme. So ranked-based correlation does not allow for any extreme outliers because everything gets a rank by the order it is. Something can't be large in magnitude. So ranked-based correlation destroys outliers and also removes a lot of heteroscedastic issues with spread. So if you noticed over here, you would say the rank-based correlation. So the correlation among the ranks between weight and horsepower is 0.7746, indicating a very strong, I'd say slightly strong, positive rank correlation. Does that make sense, Abby, right there? So the correlation among the ranks of weight and horsepower are strong, positive, where we see higher ranks of weight indicating higher ranks of horsepower. Now, the correlation, which we're going to use Spearman, remember, the correlation right here is 0.658, which indicates a strong positive or moderate strong positive relationship between weight and horsepower. But I'm wary against using Pearson due to some outliers and a little bit of heteroscedasticity. Good to see your meat. So does that make sense, Abby, on how we decided? If there was a mean of 20, how far off the numbers would be outliers? Well, it depends. Depends on the scatter, William. Good question, William, right there. Something would be an outlier depending on how many standard deviations it is away. If it's more than like 2 standard deviations, outlier, or more than 1.5 IQRs above Q3, more than 1.5 IQRs below Q1. How would you interpret Spearman again? So the correlation among the ranks of weight and horsepower is 0.7746, indicating a pretty strong positive rank correlation between these two variables. Does that make sense? Because it's the correlation of the ranks. We rank them saying this is the first, the second, the third, the fourth, the fifth, versus Pearson in words. So Spearman would be the correlation among the ranks of weight and horsepower is 0.7746, indicating a strong positive rank correlation between the two variables, weight and horsepower. What is R squared for this problem? I can estimate it. We have to select all the variables for a single... Yes, for the univariate analysis. I think you're asking about Meath. Mm-hmm. What is R squared for this? What is R squared? Can anyone calculate it? You might. I think you're using Spearman, which we really don't do it with Spearman. Good. You got 30,000 points for there. R squared is calculated from Pearson's R. So even though I know that's why I kind of threw this out here. Even though we are saying Spearman's the better way, Evan, you're on the right track. Evan, very close. I see what you might have done, Evan. Good. We got to throw Evan 1,000 points. Evan, that's kind of close. And Sarah, we got to throw 1,000 points. That looks correct, Sarah. So I'm guessing Sarah took R and squared R, right? So Sarah, great work. R, square R, and there it is right there. Great work. So you can also get this right here by just going to summary. And that number we just got is right there. I was guessing you did 0.6 times 0.6, which is 36. And then for bivariate analysis, let's say I select survey 11, then all my variables should be... you can switch data frames if you want. You could. Oh, that's right. Yeah, I see what you're asking now. Yeah, you can switch data frames. Good. Yeah, thank you. DF. I thought DF was degrees of freedom for a second, DF being data frame. Yeah, you could if you really want. If you're not finding anything cool, or you want to switch it up and compare years, maybe that'd be interesting. Say like this one was a Spearman, but this one was a Pearson. Yeah, good job, Meath. And there's R squared right there. And then I think you were talking about the slope earlier. The slope is this right here. This is the slope coefficient, which can be also found by doing the coefficients of the x's right here. And there's the slope coefficient. So that is the rise over run of the line. And if we want to see the linear model, we can just visualize our model right here. And there you go. There's the linear model created for us right there. So if you notice this model M, I already visualized it right there. It's really easy to get a linear model and to make it and summarize it right there. Any other last questions? Let me do this. Advanced. I know people had. See you. What do they got right here? I'm looking over people's models. That's a GM smooth. Aesthetic. Okay. Let me see. Mutate. No, that one's going to be too hard to do. We got class in 15 minutes. Ah! Is there any questions about how to make pivot tables? Yes. Yes. For Pearson, do we just say there is a correlation between... Yeah, and then you would maybe describe it as weak, positive, negative. Remember, correlation is what? What are the four things? This is good review for 201 also. Correlation is what four things? Correlation has what four characteristics? Not the conditions, but what are the four characteristics? Great job, Blake, right there. Direction, strength, form, unusual features. So, or I like to say strength, direction, form, unusual features. So those are the four characteristics right there. Nice job, Natalie, right there. Strength, direction, form, unusual features. Direction being positive or negative. And great job. Like, really impressed with the answers here. Positive, negative. Strength being how tight the points are around the form. How strong is this one that I just drew right here? Weak, strong, moderate. What do you think? This one that I'm drawing right here, how strong is that? Super strong. Super strong. But what's the correlation on it? Let me send out the announcement. Say, class in 13 minutes. What is the correlation on it? What is the correlation? I'll look over there. People should be saying correlation close to 0. 0. And then I got to look to see if people are having problems with the exam. People are taking it early. There it is, upcoming. I was like, where is it? It says the same thing from the last one. Review for test 1. Let's call it part 2. Part 2. Part 2. Okay, I think I've got it. Review for test 1, part 2. We don't have much music today. Announcements. Plus. Class in 12 minutes. Reviewing. See you soon. Click y'all. There we go. We got it. Sending announcements so I don't forget. Okay. Am I doing anything this weekend? I'll probably just hang out, play some Elden Ring, relax, have a good time. There's multiple choice, true, false, multiple choice, true, false, numeric entry, all that good stuff, like canvas content. I thought the 0.89 strength represented the cluster. The 0.89? Oh, the first one, yeah. This might be 0.89. Yeah, that might be R equals to 0.9. This one would be R equal to about 0. So the first one would definitely be strong, positive, linear. The second one would be something non-existent. Good stuff right there. Any last 2 questions? Got about 10 minutes. Wait for the cluster. Does that make sense? Why to which one? Because this right here does not have a what. It has a R close to 0 because it does not have a what. Correct. Strength and linear correlation are not the same thing. Good answers right there. So this does not have any linear strength. It's still very strong because it's tightly around the parabolic form. So does that make sense? It's still tight around the parabolic form, so it's strong, but it doesn't have any linear strength. Correlation only measures linear strength. So you can have a strong relationship that's not linear. Is the more random p-value or more likely to have a random chance? The lower the p-value, the less likely by random chance. Statistically significant, here, I'll write that down for you. Statistically significant means p-value below 0.05, which means it is unlikely by a random chance. Higher p-values mean what we saw was more likely by random chance. Not statistically significant. How's that look right there? Let's say, does that, let me go away from it. Boop. There we go, right there. Awesome. Good questions. What I was saying was that it has a strength of 0.89 for the first one. Why would you provide a number if it's not linear? That might show that it doesn't have linear strength. Good question, Evan, right there. So you could provide the number and be like, oh, does not have linear strength. I think, is it, I put the right time on this, all right? Yeah, I did. Good. Awesome. I was like, wait, did I put the wrong times? Awesome. With that, we're going to head off right here, everybody. Excellent work. Until then, bye for now, everyone. Bye.